Okay, so now that we know how species change over time, we are actually going to learn about how we study that and how we classify and kind of date and graph the living things that have been present on Earth, and so that we can kind of see how they have changed over time and kind of just get a good visual of that. So our essential question for today is, how do we know that life has evolved from the geological time scale? So our learning targets, we have two for this section, is learning targets 19 and 20. So 19, you should be able to identify, describe, and determine the sequence of major events in Earth's geological history, and you should be able to explain the causes and effects of mass extinction. So now we're going to find out what part in our Earth's history, how it's been sequenced, when have things appeared, when have they disappeared, and why things have disappeared in regards to mass extinction. Okay, and so let's pull this up. Okay, this website will actually also be linked to on our own website. It's a really good website to look at the geological time scale. So this is a link that's on the website. Please make sure you look through it after you view the video of the notes. Okay, so a geological time scale. That time scale is basically showing the appearance or disappearance of types of organisms throughout Earth's history. So the geological time scale looks similar to this. So basically, it's been divided up into eons and eras, which is the first category in this first column. Then you've got your periods, and then your epochs, and this tells you the millions of years ago. So we've got different areas in our time, and you're going to actually learn about those different periods and figure out what organisms lived during that time. Did they become extinct, or did they survive? Okay, so how do we classify the time on the geological time scale? Okay, so eons are the largest time group based upon the abundance of certain fossils. So if we go back to the geological time scale, there we go. Eons, the Precambrian is an eon. It's, even though it's under the era, it's actually an eon. And then the Archean and the Proterozoic are actually eras. The Precambrian eon is the longest time of our geological time. And that was where there wasn't a whole lot of living things. That was when the Earth was just forming. It had a very molten lava exterior, and we'll get into what it looked like back then. So eons is the longest period of our geological time. And pretty much the time scales are classified by the appearance or disappearance of fossils. Era is the next longest time scale in our geological time, and it's marked by major worldwide change in the types of fossils present. So something happened to change it from one era to the next, whether it was a mass extinction that caused some fossils to disappear and then new ones to appear. That's what you guys are going to be able to find out. Periods are the second longest time. There, the eras are subdivided into periods. They're characterized by the types of life existing worldwide at the time. So each period had different types of life existing. And then the last one's your epochs, which are periods are subdivided and characterized by different life forms as well. So those are the major ways that the geological time scale is classified. So now let's get into the meat of our geological time. So fossils we've talked about before, they're the remains of once living things. So this is what drives our geological time scale. One of the major fossils that we use are trilobites. Trilobites inhabited the oceans for more than 200 million years ago, and they were found in the Paleozoic era. Some became extinct, others evolved into new species. The species show different characteristics, and that helps show how the species have changed and adapt to the environment. So fossils help show us change, help show us how living things have adapted. So trilobites are what we call index fossils, and we use those a lot. This is what the trilobites look like. We use those a lot to study the Paleozoic era. Okay, so now let's get to the parts of the geological time scale. So the Precambrian time is the largest part of the Earth's geological time. It contains the Hadean, Archean, and Proterozoic eon. So it's made up of 3 eons. Little is known about the organisms because the rocks that would have contained fossils, they've either been buried or melted, and there was a lot of volcanic activity that could have destroyed the fossils and not allowed fossils to become not allowed living or the remains of living things to become fossilized. So we don't know a whole lot about the Precambrian time. What we have found, what fossils we have found in the Precambrian time are what we call the stromatolites. Those are cyanobacteria. These are what we say are the earliest life forms. Cyanobacteria can photosynthesize, so they could make their own food. And that's what we found as one of the earliest life forms. We also found some fossils of invertebrates. Invertebrates have no backbone. They appeared at the very end of the Proterozoic eon. So the Precambrian time, Hadean, Archean, we did not find a whole lot of life in those two time frames. But in the Proterozoic is when we found the cyanobacteria and some invertebrates. The invertebrates we did find were similar to jellyfish, worms, and soft corals. So to give you an idea what the Precambrian time looked like, pretty much the surface of Earth was had a lot of volcanic activity, and there was a lot of magma and lava cooling and hardening, and so it wasn't a very pleasant place to live. And that's why we have not found a whole lot of existence of life during that time. Okay, the next time period is the Paleozoic time. This is where we started to see a lot of marine organisms because we started to see oceans. Oceans covered most of the Earth during the Paleozoic time period. Okay, so we started to see marine organisms, not any land organisms. We started to see organisms with hard parts, with shells at the beginning of that era. That's where we started to see the trilobites, which I showed you above. Invertebrates, those were the animals with the shells. And then we also started to see vertebrates with backbones. Those were your fish without jaws, like eels. Okay? At the end of the era, we started to see animals go to land. So there was a little bit of land, so we started to see that animals started to adapt and go to the land. What also occurred is the Appalachian Mountains were formed during the Paleozoic era. Now, unfortunately, at the end of that era, we had about 90% of all marine and 70% of all land species died off, so they became extinct. One of the reasons why we think that might have happened is that there was a big change in climate, meaning it got warmer, and so the sea level lowered because there was evaporation from the ocean. There started to be some mountain building and Pangea. Remember we talked about Pangea when all the land masses were together? That started to form. So that caused the seas to close. So if you run out of ocean, then there's going to be less marine animals. They're not going to have enough space to evolve. So we lost a lot. That's why we lost about 90% of our marine animals, because they lost their living space, their habitat. Because there was an increase of volcanic activity, that's why we might have lost a lot of our land species. And there was also a lot of asteroids and comet impacts during that time that also caused a lot of our marine and land species to die off. To give you an idea of the Paleozoic time frame, because it was mostly a marine time era, these were some of the marine organisms that we found fossils of. Okay, there's your trilobites. Okay, this is what Pangea looked like. So this is where all the land masses were joined together. So if you notice, okay, when that happened, when the land masses started to join together, where the ocean used to be, there no longer is. Now it's one big land mass. So that's why the marine animals lost some of their habitat, because the land masses came together and there was less, and that caused the closing of the oceans. So that's the Paleozoic era. Okay, the next big era is the Mesozoic era. So this is where actually Pangea started to break up. So the continents started to separate. This is where we had our dinosaurs. We had birds, mammals. We had what's called gymnosperms, which are evergreen trees, angiosperms, which are flowering plants. This era ended about 65 million years ago with a major extinction of land and marine species. A big asteroid collided in the Yucatan Peninsula, causing a huge cloud. Oops, spelled that wrong. Let me fix that. A huge cloud of dust and smoke to rise into the atmosphere that blocked out the sun. The larger plants started to die off because remember, plants need sun's energy to photosynthesize. So those larger animals, the dinosaurs that were feeding off the big plants, okay, they started to die off because they didn't have enough food. And then the larger animals also died. All the organisms that you see around us today are descendants or survivors of the Great Extinction. So that's why that was the rise of the small mammals, because after that asteroid impact, the only living things that survived were the ones who could survive on smaller plants. So to give you an idea what the Mesozoic era looked like, of course, it's got a lot of dinosaurs were in that era. Okay, here's kind of a picture of the big asteroid impact. Oh yeah. So after this era is when humans started to evolve. So we're still not here yet. Okay, these are the small mammals that started to evolve after the asteroid impact. So we've got our woolly mammoths, and then we've got some of our deer. Okay, and then this is when after the Mesozoic era, we started to see the first sign of humans. Okay, the last era that we're going to talk about is the Cenozoic era. So this is what we call recent life. Okay, it began about 65 million years ago. Many mountain ranges formed. Okay, mammals started to become larger because plants started to grow again because some of that dust, gas, and clouds started to disappear. And Homo sapiens, which is what we evolved from, started to appear about 140,000 years ago. So we have not been around for very long. So the Cenozoic era looks like this. Smaller mammals, similar to what we see today. Okay, so if you take a look at the geologic time scale we just went over. So the Precambrian time, remember, is broken down into this one doesn't have it, but the Hadean, Archean, and the Proterozoic eons. That was the longest period of time that that has been on the geological time scale. Then here's our Paleozoic era that we were talking about that had a lot of the trilobites and the marine organisms. It's broken up into a lot of different periods. The Mesozoic, where the dinosaurs started to, that's where they were around, is broken up into your Triassic, Jurassic, and Cretaceous period. And the last era that we just talked about, the Cenozoic, is broken up into the Tertiary and Quaternary periods. We are right now in the Quaternary period. Okay, this is the Quaternary period is when humans started to evolve. Okay, so that's an overview of our geological timescale.